What is the Latin word for liquid? Does anyone remember? As it relates to the human body? There's actually an English derivation, that's fascinating. Begins with an H. Yes, Milena?
Humor.
Humor. And if you're a humorous person, it meant you had the right kind of liquid flowing through your body. Okay? So what are the liquids that are in the eye? There are two types. You could see that too, the names from the Frank Netter. Okay, now what I've created after I've trimmed the fat, you could see here, it's more of a ball, right? This is now, we're holding the eyeball. And what I'm going to do is I'm going to begin cutting through the sclera. And again, thankfully, I want you to watch this. Look. Okay, here I have a sharp scissor. I'm going in like this. But what's happening? What's happening here? Garcelle?
The scissor is pushing on the eye, and the eye is just pushing back.
Exactly. Again, thankfully, going back to Victoria's comment, right? It would be very troubling if I went like that and it immediately went in, right? Because that means any splinter or anything that would get into your eye could potentially cut it, all right? So now, I'm going to be I'm going to push really hard now, okay? And even there, right, even trying to push really hard, it's taking some effort. Actually, you could tell some liquid is now further coming out. Let me stand up because this is a struggle. Okay, let me go in. So I'm okay, there. Now I've just penetrated. Okay. Let me now take this out. Actually, David, would you see if there's another scissor? Maybe, the scissor is sharp, but maybe it's actually too dull. Oh no, I have it now. Okay, good. Okay, so I'm cutting now through the sclera. And wow. Okay, wow. Can you see? Oh, almost like a pearl in the oyster, okay, but much more beautiful, right? What do you see? Someone, describe. Yes, Madison, Dakota.
I think so. I could see liquid.
You could see liquid, right? Good. Describe colors, describe shapes, other kinds of things.
Kind of oval.
Oval, yeah, good.
Really dark inside of the...
Yep, it is dark. Okay, we'll get to that. Milena, what do you see?
The pearl-like thing in the center, is that the lens?
It absolutely is the lens. Let me take that out. I didn't expect that it would be so evident. Okay, but here I have the lens. Okay, now, this particular lens is very cloudy. Okay, I'm surprised it is so cloudy. I had hoped that it would be totally transparent. Or if not totally transparent, I had hoped that it would be partially transparent, that you would be able to see at least color or light pass through it, slightly. So it's possible that that's a function of the preservation, okay, or it's possible that the cow had some cloudiness of the lens, okay, and therefore potentially had poor vision. But what we're going to do is we're going to cut the lens as well. Because what's interesting about the human eye, right? A baby, and maybe you know this, right? A baby's, if you were to take you, okay, what's the percentage of your head compared to your whole body? Nick, what would you say?
Can you repeat that, please?
Yes. What is the percentage of your head to your body?
I'd say, I guess, 20%.
Oh, a full 1/5?
Maybe 10%.
Yeah, I'd say it's more like 10%, right? Okay, but what about a baby?
It'd be more because the baby's body is smaller.
Exactly, right? The baby's body's smaller. The head is probably 1/3, right? Of the whole length of a baby. What do you think the eyes? The eyes, your eyes now relative to the entirety of your body compared to a baby's eyes relative to the entirety of the body.
The eyes would probably be, I'd say, I guess, like maybe 1 to 3%.
Okay, but if you look at a baby's eyes and the relative size compared to your own eyes, like here your head went from 33% to 10%. But did your eyes shrink in relative proportion that much? Like, what's the size of an eyeball of a baby compared to you, a growing, kid into adult?
Right. I didn't understand the question fully. The eye never changes size.
Right. The eye rarely changes size. However, we're going to cut this open, okay, this lens, and we're going to take a look at the lens. But let's see what else is in the eye. So I'm going to cut this. Now we have this jelly-like substance, okay? This jelly-like substance. This jelly-like substance is called the vitreous humor. Vitreous. What does vetro mean in Latin? Does anyone know? Remember? Okay, what does vitro mean? Garcelle, you have your hand?
Glass.
Glass. That's exactly right. Okay, so this vitreous humor is called vitreous because if you look at this, it's jelly-like, right? Can you see it in my hand? It's reminiscent of glass. Okay? So it's called the vitreous humor. Vitrification means turning something into glass. Actually, I see Callie dropped out. Let's get her back in. Okay. Now, what do we see here? Can you observe? Elena, what do you see?
Well, that area would be the vitreous chamber.
Yep, good, perfect. That's exactly what it would be. And we basically sliced it in half. And notice the lens just came right out, right? Okay, now, do you see anything here? Oops. Do you see anything there? Describe what you see. Let's see. Garcelle?
I see lines that kind of look like veins, I guess.
Yeah, right. They kind of look like veins, right? And where are they headed? Where do they lead to?
They look like they lead to the outer part.
And if you go the opposite direction, they lead
To the inside of the eye.
to the very inside. Milena?
Would that be the retina?
Well, yes, they're on the retina. That's the entirety of the back that you see. But what I see is almost like a star of those lines with a center. And if you point to that center, which is right here, and I turn this over, what is that? Milena?
The optic nerve.
The optic nerve. Okay? So you could see the retina is actually fully attached. But watch this. Has anyone heard of a detached retina as an eye condition before? Yep, right? A lot of you have. Well, watch this. Look how easy this retina comes off. But yet, it doesn't come off where? At that one point that it's connected to the optic nerve. Right? Okay? You see that? Now, if we look at the other side of the eyeball, let me take this off now. What do we see? Let's see here. What do we see? Laura, what do you see?
I see that it broke with like the alveolar is basically a shield protecting it.
Okay, great. Actually, there is a shield protecting it here. And if we turn it over, what we're going to see is actually the cornea. And there is a frontal chamber called the aqueous humor. But what we see is a big hole, right, where the light initially passes. So essentially we're looking at the pupil. And if I turn it this way, it's black. What color are nearly all cows' eyes? Do you ever see cows with blue eyes? Well, rarely. Nope. They're nearly all dark-eyed. And what do you see here? What color? Everyone?
Black.
Basically black, right? It's a dark, dark color. Well, that's the pupil, okay? And if I were able to take the pupil out, it's not that easy to take the pupil out without tearing. Okay, basically you have this ring, which would get bigger or smaller according to how much light was entering the eye. Do you see that hole? Right? Okay, that's exactly the same that you have here in the iris. All right, so that's what I'm holding. The pupil is the hole. The iris itself is what I'm holding here. Right? Okay, good. Now, let's take a look at this lens, okay? What type of lens is it? Remember the types of lens? Convex, concave? What type of lens is this? Who remembers? Victoria?
It's convex.
It is. And it's not just a convex, because it's convex on both sides. It's called a... You remember, Victoria?
Double convex?
Exactly. It's called a double convex. That's exactly right. Let me take the scalpel and I'm going to cut it, and let's see what we see. Okay, interesting. Okay, what do you see? Someone describe. Isabella, what do you see?
There's a little black dot.
Yes. Actually, let me take the black dot away, or because that might be, I don't know if that's, well, no. I think that's just, well, no, it could be. It could be a spot, which could be a defect. Okay, you never know, but that's right. I thought it might be just an artifact of the dissection. But what else?
It looks like it's, like a light-ish ring around it.
Yeah, that's right. Actually, you may not be able to see fully because of the camera limitation, but who has had a gobstopper or one of those hot cinnamon things? When you crack it open, what do you see? Victoria?
Well, with a gobstopper, if you crack it open, you see like the cross section of all the layers.
Exactly, right? And much like that, the lens, as the cow is forming, right, in his mother, the lens is forming by deposit of layer after layer after layer of the special cells that form the lens. And you could see that here, right? Okay, now, let's just go quickly to the screen again, all right? Wiping my hands just a little bit here. Okay, I'm going to go to the screen. Let's see. How can I get the whiteboard now? Why don't I see the stuff, the options coming?
I think the Zoom is too big. You want me to try to get it up?
Yeah, can you get the smartboard up,
Yeah.
David? Thank you very much. Okay. And we'll just have a very quick review on how this can make you see. Any questions on anything that you saw? No? During the dissection. Notice how opalescent this is. This is in the back. This is behind the retina. Isn't that beautiful? So it really almost is, if I put that lens there, even though that's not where it belongs. But isn't that beautiful? Right? Really almost like a pearl in an oyster.
Get the screens up.
Which is just, again, the beauty of God's creation. Okay, good.
I'm gonna shut. Can you shut the light? If
So here we have
Thanks.
the lens, right? I'm exaggerating the size. Here you have the hole, the pupil. The iris controls how big or small. When it's very bright outside, the pupil will get smaller. When it's dark, the pupil will automatically get larger. So whatever light is in the ambient will come in, okay? So you have parallel light rays from whatever object it is come in. They bend. They come to a point. They continue. They fall on the retina. Now, this is one way of representing it, okay? But notice what happens. If I have a tree, or I'm looking at, let's say I'm looking at a man, the head is here. If I trace that head to the lens, and then because of the bending of the light, and what's the bending of the light called, everyone? Yep, refraction, exactly. Because of it, where does the head end up? And where do the legs end up? Milena?
Well, what happens is it turns upside down.
It turns upside down. So your retina is picking up an upside down image. But thankfully, as those impulses travel through the optic nerve to your brain, what is your brain able to do? Milena again?
Your brain is able to flip the image that we perceive it in the right side.
Exactly. Thankfully, right? Thankfully that happens because our experience from day one of being born is seeing the world right side up. Okay? And that happens somewhere along here when it gets into the brain itself. Okay, good. Now this is one way to represent what is happening. Another way to represent, a more simplistic way, is to say that light enters and the rays converge to an image on the retina. But that's not exactly what's happening, okay? But it's fine to represent it that way too. All right, now, let's go over again magnification, okay? So we have the eye here, okay? The lens, the opening, the retina, and now we have a magnifying glass here. Remember, and let's see if I could do this to scale, okay? If I have a bug here, and I have a magnifying glass, the rays are going to continue, okay, and they're going to get to the retina. However, what the retina is now going to pick up, okay, is not the real image of the ant, but the virtual image. The retina seeks to understand where is that image coming from. And if we trace back the light rays from here and here, the brain thinks that those rays are emanating from something way over here that would represent a very large ant. So the brain is tricked to thinking that the image originates here by virtue of placing that glass there, that double convex lens. And there you have, again, magnification. Now, it's really not a coincidence that lens making. Who remembers Vermeer and the camera obscura? Yeah, good. I see a lot of hands there. Milena, just give us a hint.
The way that the camera obscura worked was that it projected the image into a larger way, so that way he could trace the general outline and then paint it.
Yep, exactly. Now, so who was the one that we think may have used it? The artist?
Vermeer.
Vermeer? And who remembers who Vermeer's close personal friend was in Holland? Does anyone remember that scientist name? Oh, you do remember, Milena. Go ahead.
Was it Leeuwenhoek?
Leeuwenhoek, von Leeuwenhoek, Anton von Leeuwenhoek. And what was his profession? What is he known for? Brian.
I kind of forgot, but I think it's that movie Lenses.
Lenses! That's right. Now, what time period are we talking about? What time period? Yeah, Milena?
This is around the 1600s, late 1600s.
Okay. And remember, in 1609, 1610, that's when Galileo turned the telescope to the sky and began seeing the stars, the planets, right? Jupiter with its 4 moons, okay, the Galilean moons, and that whole world began. Then we also had the microscope with von Leeuwenhoek, who was able to see tiny, tiny things magnified. It's not a coincidence that the development of the lens as an instrument in optics comes not far after Leonardo da Vinci dissects 30 people and has drawings of eyes and lenses and understanding how that works. Okay? So, glass making and grinding and perfecting lenses opened up really the era of modern science. Okay, because the telescope was invented there in Holland, and then Galileo pointed it to the sky because it was used first as an instrument of war, right? Figuring out whose ships were approaching fast, okay? But then when it was turned to the sky, the whole universe opened up to man, right? So much so that in his preface, right, Galileo says, you know, God, who am I that you chose me, the first human being of all time, to see, you know, the greatness of your creation? Okay? All because of this, all right, and what we've done today.